Our next guest is a freelance CG generalist and Houdini FX artist. He's going to show us a little bit about his work in Houdini. Please welcome Tim van Helsdingen.
Oh. Oh, hi. Oh, whoa, holy shit, that's loud. Okay. Um, well, hi. So I'm really glad to be here at Us by Night. I was actually gonna be here anyway. I already got my ticket, and then they asked if I wanted to be here as a speaker, so that was kind of cool. Um, so yeah, the topic of my presentation is how do Houdini, and how it's actually very much like playing with Lego. But yeah, let's first introduce myself a little bit in case you've never seen any of my work. So my name is Tim van Helsdingen, and I'm a freelance Houdini artist, and I mostly work in advertising, so both VFX and motion designy stuff, and also make online learning content for Patreon and Vimeo and other social media stuff. So I'll just quickly show like a demo reel thing that I edited together, and then we'll go into the presentation itself. So let's watch. All right. So it was a showreel thing. Um, so yeah. So my presentation is going to have a lot of memes. So I think if people actually understand the memes, we can gauge the age of the audience a little bit. Anyway, so I want to talk a little bit why I picked this topic. And the thing is that also because I make learning content and stuff, I really notice online that a lot of people want to sort of get into Houdini because they think it like it seems really cool. But everybody seems to think that you have to be like a programming wizard, like a mastermind or something. Like you have a lot of people like posting like this on the Houdini Facebook page, like they think, oh, I need to know Python and C++ and everything before I even get into Houdini. So this is basically people's face when they hear the word. And I'm gonna try to, with my presentation, to show that it's actually not that bad and you can just get started and make cool things by showing a lot of my work that I did over the past years. And I'm gonna show a lot of old crappy stuff and how I hacked together a lot of things and that still turned out super cool. So I'm gonna compare it a lot to Lego, actually. And what I think is that Houdini is really a lot like using Lego blocks. So if you look at it like this, it's basically the same. I mean, there's like Houdini nodes and you have Lego nodes. And when you have a box full of Legos that you're gonna play with, in the beginning you have no idea how to build all of the buildings and make cool stuff. And that's the same with Houdini. But after a while, you start recognizing patterns, like how can you click stuff on top of each other and start making buildings and start making cities. And that's also how you can do it with like Houdini nodes and like make really cool stuff. And the same with Lego. If you step on a Lego brick, your feet will hurt a lot. And it's the same with Houdini. If you do the stuff wrong, your brain will hurt and it will be unpleasant. Let's roll back for me to the year 2015. I got into Houdini, learning Houdini in December of 2015, which was like during Christmas time, and I was like, what else do you do during Christmas? I mean, you're gonna learn new software because you have free time. Yeah, but a couple of things happened for me during 2015. Why I got started, wanted to get into Houdini that year. So I quit my job that year to start freelancing. Because I was doing a lot of Cinema 4D stuff, After Effects stuff. I was doing a lot of like lower end work, which I didn't really like. I wanted to do more high end productions, and I kind of wanted to get into like doing FXy stuff. And first I thought, okay, I'm gonna be like a RealFlow expert or something because I was doing RealFlow for a while. And then I attended end user event in 2015, and I met super cool people there, including really great friends, and like one of them is here as well. I'm not sure where he's sitting, but they were all like recommending and going raving over Houdini. And then also Maxon introduced Houdini engine in that year, and I thought, oh, then I can make like plugins for Houdini for cinema or something. I ended up like going into Houdini and never really going back to cinema. But anyway, I'm gonna show two really my first test that I ever did in Houdini, and they're pretty bad, but I'm just gonna show that. So I made a ball of dough, and I made a shattering sphere. So yeah, that was the first couple of weeks, and I figured out how to do that. Like, whoa, amazing. So amazing. So now let's just take up a gig with a 1-minute rigid body simulation, and then that'll be fine. I'm an expert now. So yeah, that's the first project I'm going to talk about. So it's Bosch by Night, which I did at Studio Mr. Beam. And that was when I was still also doing a lot of Cinema 4D and After Effects stuff, but there was a sequence in there with which required a longer rigid body thing, and I was like, okay, I'm just going to try to do this in Houdini. It'll be fine. So what this project was about, it was, you have the painter Hieronymus Bosch. He was a famous painter. He lived 500 years ago. And in Den Bosch they did, like it was the year of Hieronymus Bosch. They had an exposition with his work, but there was also going to be a projection on like the building where he used to live and work. And we were going to tell the story about that. And in that 12-minute show is a part where the building was on fire, because that actually happened 500 years ago. The building was on fire, and I guess that traumatized the guy. That's why he was painting really weird stuff. So that's in there, and then demons start coming through the building, and then the building collapses, and that's all time to the whole thing. And there's no time to show the entire 12-minute thing, of course. So I made a quick edit of that part of the sequence. And it was projected on the building, but I'm showing mostly video which I just recorded from the VR experience that I made from it, because it was just easier to record it and it's just easier to show here. So I'll show that sequence. So this was done like early 2016. It was the first thing that I ever used Houdini in. So I did the 3D, the compositing, and the rendering. I didn't do the characters, that were done by someone else. I really like that project, even though it's quite old by now. But it was all hacked together because I had no idea what I was doing. So yeah, basically hacking it together. So I didn't even know how constraints worked, which is basically a thing that like you need for rigid bodies. But I didn't know how it worked. I knew how I could activate pieces. This is what I did on the silly sphere thing that I did as my first test, and I knew how to time shift stuff. So, I mean, I knew a couple of the Lego bricks. I mean, I knew time shifting, activating pieces. I knew how to Voronoi fracture. So what I thought, okay, instead of like doing it the proper way, I'll just blast out certain parts of the building, and then I'll just blow them out, and then I'll merge them back in, and then I'll just time shift everything into place and time it to the music. So nothing is interacting, it's just separate simulations merged together, and I just fixed everything in compositing to make it look like it works, and you don't see it in the final thing, and it looks fine in the final thing. So that was just with very limited knowledge, I still got that thing together. It was a week before the premiere, and we were super excited about everything, and then something happened. So I will show you what happened.
What do you say after that one? Brutal, savage, wrecked, absolutely taken down.
Yeah, so 2 of the buildings we were going to project on actually collapsed. It was the first time in Holland that ever, like, an old building actually collapsed. So there was some construction stuff that like didn't go properly as planned, and then I was laying in bed and I got a text which like, yeah, the building collapsed, and I was like, yeah, I know. I mean, that's what I've been working on for the last couple of weeks. So like, no, the actual building collapsed. So I looked it up and I was like, well, that was what happened. But luckily nobody got hurt and they decided to still move along, but we needed to redo the entire thing, of course. Because, I mean, it was all aligned to the building, so, I mean, spot the differences. It's like we had to shift the whole thing around. I mean, that's what when I discovered that proceduralism is super awesome, and I was able to redo all of the 3D in like 2 or 3 days, which I would never have been able to do if I did it like any other way. That is what really clicked for me, that like, oh, this is a really cool thing, and I really want to get more into like learning this type of stuff. So that was for me really an incentive to like put more effort into the whole Houdini learning process. Learning more Lego bricks. I'm going to show the thing that I did my first Houdini tutorial for. It's a pretty bad thing, but at the time I thought it was pretty cool, and other people thought as well. So I did my first tutorial on this effect, if it wants to play. So it's pretty ugly, but it's a smoke sim, and then it goes into flip. But it was for me the first time when I started like piecing stuff together. Like I knew how to do certain things in Houdini, and you start making connections after a while if you've been doing it. Like this was when I was 3 months or something into like learning Houdini. So I did understand what voxels were. So if you do like a pyro simulation, you have it's basically voxels, which are 3D pixels. So if you have an image, you have a certain amount of pixels. In a pyro simulation, they just also go in the Z space. So then you have those things. And I thought, well, if you have that, you can also add a point in every voxel. I mean, why not? So then you get points in the thing. And because I already did some tests with like Flip before, and I knew how Flip worked, like the fluid simulation stuff, I was like, I can add it into a Flip simulation. So then you start like building, you start building up your knowledge. Because you start figuring out these little pieces, and you start building them, like bringing them together. So yeah, then I knew how to do a basic pyro from a shelf. I knew how to create points with values on them, and then I knew how to add them to Flip. And then you reapply the values, and then you get that thing. And that's really what Houdini is about. It's about taking data and then applying it to other stuff. So that's when it started sort of slowly clicking. So these personal projects are great for learning, so I did a couple more. I did this one later that year, was the first time that I used Redshift. I'm not going to talk about this thing, but I thought it was still pretty cool, so I wanted to put it in. So it was a full CG thing of boiling water, where I really learned more about doing flip and using velocities to affect stuff. So I'm not going to show the entire breakdown thing, but well, if you want to watch, okay, I'm going to quick that. But this is like I did a lot of those personal projects during that time. So then that was the first year done, and I actually knew like the basic stuff of like how stuff works. So I had like the base skills, and now it was time to get the new bricks for technical skills. So second project I'm going to talk about is the Spin Awards 2017. I did it at Color Animation Studios. So it was actually a really cool project. A lot of technical stuff. I worked on about half of the shots, and I built most of the setups for all of the things. Well, I'll show you the video. I still think it's a really cool video, and then I'll go into like 1 or 2 elements of it because I don't have time to cover all of the things. still think that's a pretty cool project. Yeah, thanks. I actually did a talk about that before at end user event in 2017, but it wasn't recorded, so I might as well like say stuff about it. So there were a lot of growing wires, as you might have noticed. So there's a deformer in Houdini that can do like wire deforming, but it was super slow, and we needed like a lot of wires with a lot of points. And because it wasn't multi-threading properly, I figured like we need another way to do that. And we need to get a little bit mathematical. So started building a sort of a very pretty simple setup actually to do like wire deformer. So I just want to get into a little bit how you come up with something like that. It's a very rudimentary way to do it actually. There's probably better ways. Okay, so let's say that's our bundle of wires. I'm going to do it like that. So imagine that they're twirly. I guess I didn't make them twirly here, but they could be twirly if you want. And then you just take like a center curve, and then you edit the center curve, so you just deform the points. And then what you have is you have the two curves. And they have the same amount of points. So what you can do is like every point on the curve has a point in 3D space. So if you just subtract 2 points in 3D space, you get like a difference, you get a vector. And so I visualized the vectors over there. So it's basically you subtract them, then you get a vector pointing one way. If you invert it, get a vector pointing the other way. Then what you can do is you can look at the original geometry and just look around every point with the edited curve with the new vectors as a second input. And then what you can say is, okay, wherever you find this value, just add it to the position. And because like doing this stuff like in Houdini, you're building it yourself, is completely multi-threaded. It's a lot faster than x16 tools. So yeah, it's just a simple example of what it would look like in Houdini. It's actually a pretty simple thing. So over there, you take position, you import the position from the second input, which is the edited curve. You subtract them, you invert them, you put it out into the normal, because the normal is also a vector. And then you do in a second thing, which is the thing over there, you do a point cloud, which is the looking around. So like you're looking around the point, and then you're telling it, what do I need to look for? So I'm looking for the normal, and then you're just pulling in the position, and then you're just adding it to the position, and then you basically created a very fast multi-threaded deformer. It's super simple. You can also do it in VEX, but at the time I had no idea how VEX worked. As I said, you don't have to be a programmer when you start out. Right now I use a lot of VEX, but this was when I slowly started getting into learning VEX, but this is what it would look like if you were to code it. Anyways, what you're going to discover, for me, it was like about a year in, where you really start seeing the power of taking arbitrary data that you can generate, and then using that data to influence other geometry. So you're starting to understand these pieces, and then you smash them together, and then you can make cool stuff. So once you understand that, then you can do anything, basically. So another shot in the thing was stuff that I just discovered when I was working on that. There's droplets, which I'm not going to talk about in this part. I'm going to get back to that later, because I did the droplets with like a flip simulation, because that, as I said before, that was what I already was sort of familiar with. But it turns out it's not really a great way to do that in flip, because I was really struggling to get it to look right. So I'll get back to that with a later project on how I solved it another way when I learned more. But I'll go a little bit about, like, the ground was also splitting up. And turns out, I didn't know at the time, is that when you have a rigid body simulation, you do it through the bullet solver. And apparently what the bullet solver does is it simplifies things. Well, I didn't know that at the time, so I was running into weird issues. So what happens is, like, I just made a weird deformed box, and I drop a ball on it. But you can see the ball is not really, it's not really following the surface. That's because bullet creates this convex shape around it, because that's faster. You can set it to concave if you want, and then it will follow it, but it'll be super slow. And if you have like a lot of objects, it's not going to work. So then you start trying to come up with ways. You start putting together the Lego blocks to try to figure out a way, how can you solve problems like that. So then what you do is you just have these big pieces, and you just subdivide them into other smaller pieces. And all these other smaller pieces can have convex shapes from themselves, and then all together they make the big piece. But they'll still have the same name in the simulation. Because when you do simulation, everything needs a name. So if they have the same name, they will just be treated as one object. And then you start discovering all these things. So like, oh, okay, so I can simplify things and like use this data to do stuff. So yeah, convex collisions are a problem. I discovered that. But then you subfracture stuff to overcome the issue. So second thing, which I want to go more into droplets. There's another project that I did. So I'm only going to talk about the droplet part here, because else I won't have time to talk about other things. But as I said before, I did it with Flip before, but here I did it a completely different way. So let's watch this video, then I'll talk about those things. Was at Color Bleed as well. So I did all of the FXy stuff, and they did all the rendering and shading and stuff. But yeah, there's also these droplets, which are this is just a flipbook thing. So there's a lot more here, but this was actually much simpler to make than the other thing, because I figured out another way to like just hack that together. So what I did, this was before Vellum was out. Vellum is a new solver in Houdini. So what I did is I just took soft bodies, like super low res, just proxy things, and I just put the gravity to the side, and I'll just let them fall through the shoe, and then have them roll down, and then deform other geometry with that. Plus, what I also did is I scattered some points on the side of the shoe, and then I would randomly move them down, and I would just like copy other spheres on it, and then add some noise to like make it look like water droplets. And I merged the whole thing together, and then it looks cool like droplets. And it was like I did that shot I think in one day, and it was instantly approved. And the other thing like took me way longer, and I went over so many iterations. And you mean you don't have to make stuff complicated, but I was at the time because I had no idea what I was doing. So yeah, here's a video that I recorded. I did a presentation on this before, so this is from that presentation, but you can just watch the thing. So I will just talk over it, I guess. So yeah, those are the droplet things. So here you have some points. So it's just scattered on the shoe surface. So you just, with like a wrangle, you just tell them, like, based on the point number, you either move more or less down as the thing goes. Then you ray them. So ray is like projecting it on the surface. Then you have it, or then you move it down. And you copy spheres to it. Hurry up, Tim. You can do it. So then you're and then you're doing some other stuff, and then you're all merging it together with the original stuff, which is the FEM simulation that I did. I think that will be in a little bit. Anyway, and then you have droplets and stuff, and you get the point. So the point I want to make is that simpler is often a lot better. As I said before, a lot of people seem to think that you need to be like super technical and like do like crazy technical stuff, but a lot of times you're just making super simple stuff, which is just easier to work with. You don't have to complicate it. Sometimes you need to overcomplicate it. Well, not overcomplicate it, but you need to be complex. But so I want to show one example of a project that I did last year. I'm gonna really quickly go over that. Not spend too much time on it, but just to prove a point. And for the next project, I have the video I didn't have because I did it at Ambassadors. And they have all the project files there archived, so I couldn't take screenshots of the HIP files, so I just made placeholder things to show the point, so you will see that afterwards. So I'll just show the video first. So we needed art directable curves, basically. So here's a placeholder car, because I didn't have the hip file that I could get to. So I made a box and I animated it. So there's that. Anyway, so what we needed is we needed to really be able to art direct the curves, because the art director wanted to be able to like exactly draw where he wanted like the lines, like the flowy lines to go. So initially, when you think like you're gonna have like lines flowing over a car, you would be like, oh, I'm gonna do particle simulations and it'll be amazing. But you cannot art direct that at all. So it's actually a super simple solution. Like the most problems we had with this project was just getting it into Maya to render, which is always the biggest problem for every project that I get into, because they rendered it into V-Ray. You have the car that was animated. They animated it. So what you do is you just put it back into a position, just in a position like in the center, and you sort of keep the transforms from the Alembic. So then you have a stationary car which you can just draw curves on, and you can like make a setup with like nice noises and nice patterns to do things, and then you just reapply the transforms from the original car that you got, and so you just and of course this is just a thing that I quickly made for the presentation. This is not from the actual project, but just to show the point. So then you just reapply it to the whole thing, and then you have a car. So just a simple example of that. It doesn't need to be complicated to make cool stuff. It needs to be easily manageable, and that's the most important thing with all of these things. So yeah, really quick over this one. I only did one effect in this one, so it's a really cool video, but I'm going to talk a little bit about the bubble stuff here. So I didn't work on any of the other effects there. I was mainly hired for this, and this was when Vellum just pretty... so Vellum is a solver in Houdini, and it came out like pretty recently when this came out. So I was just figuring out Vellum. So I'll show the video, and it's really cool, but again, I only did the inflating bubbles. Right, anyway, so floating bubbles. So here's another example that I just did from the same setup that I did a tutorial about. So there's a tutorial on that online, but it's the same setup. And since I did that tutorial, I've seen so many people posting stuff online with that. I've seen like 15 examples of people making inflating bubbles, so that was kind of cool. So I'll just really quickly go over this, else I will run out of time. You can watch the tutorial if you want to know more. Basically, so I needed to figure out how I could individually inflate pieces in a Vellum simulation. And because the system was new, you kind of needed to figure out how to handle the data. Again, that's data management is the entire thing you do in Houdini. So basically how the shapes are done, you just have a grid. You Voronoi fracture it. Again, I knew the Lego brick Voronoi fracture from way back. So you do that. You Voronoi fracture it, and you just create like a mesh. So you extrude it, and you smooth it a little bit, and then you create like constraints. So the constraints are the thing that keep it all together. That's the thing on the right. You throw that in the Vellum simulation, and you have like specific groups that you can run over. So you just animate like colors through it. So you can use these colors to do like other stuff. Because like in Vellum, you really like attributes are the data things in Houdini. And you need to be on really specific parts in order to solver to work. So that was the main thing that I learned during that. Like it needed to go over the primitives, and it needed to go over a specific group, and you just write a quick wrangle of like if the time is above a certain thing and a threshold, then they start getting more of a certain attribute, and then when the attributes get larger, then the bubbles start to inflate. And you just drive that by the noise thing, and the whole thing is procedural, so you can just like create more bubbles. So initially, with all we went through a lot of iterations of that shot. Like I had one at some point with like hundreds of bubbles inflating, and that was quite slow to sim. But like the example that's in the video was quite fast. So yeah, but like this when you start you start implementing wrangles and like just learning how solvers work, and you start doing more and more cool stuff. So yeah, Vellum. I'm working on different data types. Basically, so announcement time. So I wanna last thing I'm gonna go over is for the last couple of weeks I've been building a really cool new tool which I think will be pretty dope, which is almost done. I'm gonna go over that a little bit, and I put this in like right before I went to As by Night because I was still running in some bugs, so I couldn't really record proper demo videos. So it was put in last night. But anyway, I built a DOP instancer toolkit. A couple of years ago, I made a tutorial on how to do instancing in DOP, so it wasn't really the best way, and I kept getting questions of people like, but questions about it, and I kind of thought like maybe I should make a new tutorial, or I thought maybe I can make an easy way to do that stuff. So just having a couple of nodes that you can use in DOPs and just plug them in and everything works. So that's what I did. So it's a toolkit for emission and dynamic object, constraint creation. So I'll just show you a couple of examples and then some stuff that you can do with it. There's no rendered examples yet, because again, I had to quickly get some demos together because I really wanted to include this. Yeah, so it's multiple nodes. So it's just like a pop node. You can, for example, just say which objects do you want to emit. So you just select the objects, and then you can emit them in your DOP solver. So you just plug it in, and it works. So like now I'm emitting Lego bricks because it fit with the, that's also what the Lego example in the beginning was done with. So you just can quickly emit objects into the simulation. And just like a pop node, you just have a little snippet thing where you can just write a wrangle and then it'll do those things. But the cool thing with this, which is not possible by regular ways of emitting objects, because normally when you emit objects, you can emit single objects. But with my tool, you can also emit fractured objects, so you can have like objects that you fractured. So this is just a very simple. So right now the boxes are not fractured, but I can also say, okay, so take the individual fractured boxes and then emit them. So what you're gonna see now is that the boxes get emitted, and then they also individually fracture. So that's not something you can normally do. And this just makes it super easy. You just plug it in, then you create a constraint network. You say which what it needs to iterate on. You can just type a wrangle to set the strength and stuff. And then it'll work. So like now they're gonna break a lot faster. But that also that whole constraint creation thing, that opens up super cool things to create like really cool motion designy stuff or VFX stuff. Like for example, this is super useful if you're gonna emit like debris and you want subfracturable debris. But it also creates like super cool things, so you can create stuff like this. So you can emit boxes and have them like connect to each other and like start doing really cool stuff. But because it also works on subfractured objects, you can also do it on like boxes that are individually fractured. You can just load in random objects and have them do cool stuff. And what it also does is here's the Lego box. You can also swap out all these instances post simulation. So I'm just swapping it out with the pig head there. So you're not locked into any of the objects that you really emit. Anyway, to get back to the point of the presentation is that it was a lot harder to build than I thought. I thought it was always going to be easy. You're going to deal with quaternions and matrices and prim intrinsics. That was the first time I actually worked a lot with prim intrinsics, which are also sort of like bit like attributes, but a little bit lower level. Path instancing, all that stuff. So this is the node tree of just the instancer thing, but there's multiple nodes within the whole thing. So this will be out next week on my Patreon, hopefully, if I can fix the last couple of bugs. So then you can play around with it and make super cool effects. So I would like to, will be cool to see what people do with it. Anyway, so this is like, right now I'm doing super cool like coding like stuff. But again, when I started out, I had no idea about all the coding crap. And throughout the years, I started learning all these different Lego blocks, piecing them together, and now I can make really cool Lego structures. So just giving a go, Houdini ain't biting. You might start out like building a little ducky, but eventually you might make a really big spaceship and do Star Wars-like stuff. So apparently they're not doing questions and stuff here, but anyway, you can find my work on my website, on my Patreon, where I like put like tutorials, and also I usually upload all of my personal projects there as well with tutorials, so you can download those and follow and whatever on other things. So if you have questions, just come after the presentation thing, I guess, and just ask stuff. So I think that was the whole thing. So I hope you enjoyed and hope you will give Houdini a go and are not as intimidated by the whole math and programming stuff behind it as you might have been before you watched the presentation. So yeah, that was it.